So here's our intro video for section 8.3. You're going to be doing more graphing. You're going to be finding your VA, EBA, X and Y intercepts, domain range, all that fun stuff for graphs again. So what's going to make 8.3 different than 8.2? Well, 8.2 is on simple graphs. So I've got a few graphs right here. They look kind of similar to what you saw before, but not really. So just let me point out a couple of differences. In this first graph, you still have your end behavior asymptote that looks like it's at y equals 2. The new thing, however, is you've got a vertical asymptote here at a -3 and another one here at a +3. So you might see some graphs that have more than one vertical asymptote. That's fine. When that happens, you're going to have the curves that you saw before, only they're going to happen, somewhere over on the outskirts of your graph, kind of on the outsides here. So you have your curve here, and then this middle section I kind of think of as like no man's land. Who knows what's going to happen in here? Typically you could have some parabola shape, either opening down, possibly opening up, or if you look at our second graph, in the middle of your two vertical asymptotes, we've got it going kind of like that. So you'll just have to plot points to see what your graph is going to do on those instances. But our middle graph, two vertical asymptotes again. So you'll still set your denominator equal to 0, but you're just going to get two answers for x sometimes. And then do you see how your curves are kind of going off that way and this one is kind of going down that way? So what's happening here, and we're going to see this, there's a special case where your end behavior asymptote is not horizontal. The book doesn't draw it in, but I could draw it in just like this, and here is our end behavior asymptote, and that looks like the line, I don't know, I'd guess y equals x. So you may have a slanted end behavior asymptote. And again, your curves are just still fitting within there, just taking a slightly different shape. Our third graph, just one vertical asymptote right there in the middle, and because we can see that the curves are kind of going off that way and down that way, it must have a slanted end behavior asymptote. And so if I were to guess where it is, and I'll show you how to actually find it, I would draw it in something like that. Alright, so that's just a heads up on what your graphs are going to start to look like. You're basically going to have two new ideas in this section, vertical asymptotes and your end behavior asymptote. The end behavior asymptote, I want to take a minute and talk about this one. 3 instances to consider. Our first one right here, again, you learned how if you're finding the EBA, take the leading term over the leading term. So leading term x over leading term x, and then you learned how to compare the degree. So this degree up here, because it's x to the first power, the degree is 1, this degree is 1. If the degrees are the same, then you can just go ahead and simplify the fraction that you have. And x divided by an x is 1, so we have y equals 1 for our EBA. Now on the next example, when you go ahead and set up your leading term over leading term, we have x over x squared, and this time the degree in the numerator is 1, the degree in the denominator is 2. So if this degree in the denominator is ever bigger than the degree in the top, this is a special case. It will always be y equals 0 every single time. So if you ever have if the highest degree is down here in the numerator, then y equals 0. Now, the one thing that we have not talked about yet is what if your highest degree is in the numerator. So on this next example, leading term over leading term, so your degree on top is a 2, your degree is a 1 because it's x to the first power. If the degree in the numerator is bigger, we are going to do synthetic division or synthetic substitution. So you're probably saying, well, that sounds kind of familiar. You learned it back in chapter 5, so last term, and we'll go over it, but if the degree in the numerator is bigger, synthetic substitution is how we get our EBA. There will be a video for synthetic substitution, but I just wanted to run through it here quickly just to give you a heads up on what this is going to look like. If you look at our example here, our leading term over our leading term, well, the degree in the numerator is bigger, so I have to do synthetic substitution. So if you remember, what synthetic does is it takes the coefficients, so that 1, the 2, and the negative 1 from we learned this with polynomials. So you're going to take the coefficients of the numerator and set it up with synthetic substitution. So 1, 2, negative 1. And do you remember how we kind of had that little guy there? And then what we're going to do is we're going to divide by an x minus 2. So when you divide by an x minus 2, you guys kind of know the idea of the tricky x. Same idea. If that's a negative 2, we're going to do synthetic substitution with a positive 2 off on the end. If that was a positive 3, we'd be putting a negative 3 off on the end. And so what we're going to do now is we're going to do synthetic substitution. So if you remember, whatever this first number is just gets carried down, and now we start our pattern of multiplying and dividing. So we're going to take 1 times 2 and get 2. Remember, your answer goes up here. And then we add down. 2 plus 2 is 4. Now take 4 times the 2 over here. 4 times 2 is 8. And then we add down. Negative 1 plus 8 is 7. So here's where, there's more of an explanation I can talk about in class. But basically, this last number of 7 is, cross it off, it's not part of your answer. And because we had an x squared and we just divided by x to the first power, our answer is going to be just 1 less than this x squared. So we're going to have an x with the 1, and because that's a positive 4, x plus 4 will be our answer. And because we're talking EBA, we'll say y equals x plus 4, and that will be a slanted line. Y-intercept of 4, slope of 1. So I know that's totally different, totally weird. We will talk about it and practice it, but just wanted to show you what's going to happen with your synthetic substitution. On this example, I just want to show you your vertical asymptote. You guys know to take your denominator, x squared minus 4, and set it equal to 0. If you ever have a squared term down here, let's think about how do we solve for x. You guys know how to factor. X squared minus 4 is a difference of squares. So it's x plus 2 times x minus 2 equals 0. And we're just solving for x. So we set each of those parentheses equal to 0 anywhere that you have an x. So we have x equals a negative 2 and a positive 2. That's what it's going to look like when you get two vertical asymptotes. Our last slide here, I just wanted to show you that synthetic substitution again on another example. So if you're going to try to find your EBA, leading term over leading term, x squared over x, the degree in the numerator is bigger, so that means we'll do synthetic substitution. Now, the coefficient of x squared is 1, and then do you remember how you have to fill in, there's also an x to the first power and an x to the 0 power. Well, when you don't have these terms, you fill in with zeros. And then I'm going to do my little L shape there, my table, or whatever we call this. And because we're dividing by an x plus 1, I'm going to use a negative 1 out here. Always the opposite sign. Now when you go to do your synthetic, again, you just bring down your first number, so you have 1. And then you're going to take 1 times the negative 1, which is a negative 1. And then we add down. 0 plus negative 1 is negative 1. And then negative 1 times that negative 1 is a positive 1. And add down. 0 plus 1 is 1. So what we did last time, and we're going to do this every time, your final answer, cross off. And then because it was an x squared, this will become x to the first power, and that's going to be our EBA, y equals x to the first power minus 1. And we'll have a slanted EBA in this case. So I know it's weird, but we'll practice it. You guys will feel good about it. Just know anytime that your degree in the numerator is bigger, like up here in the corner, then you're doing your synthetic substitution just for the EVA.